Hi, in this video we'll talk about solar powered. Do you know that the Earth is receiving 1,400 watts per meter square every second on average from the sun? So you may not think that, hey, 1,400 watts is not a lot, but pay attention that this is per meter square. That means if you try to multiply with the area in meter square of the Earth, it's actually a lot of energy. So that's why if you pay attention to the technology trend nowadays, people are trying to use more green energy, and solar energy is definitely one of the best way to do it. Currently, there are two main ways of storing this kind of solar energy. The first one is called the solar panel. As you can see here, the idea is very basic, and it has been invented many years ago. And the idea is simply having those methods you learn in thermal, painting things in black color, or trying to use metal for better conductivity, and then you can store the light energy or light energy into the water, and so people can warm up the water in a form of thermal energy, and so maybe they can use it for shower, for other things as well. The other big thing which has been discovered and invented in the recent years is called the photovoltaic cells. If you are studying Excel, then you might be, you will be, or you have been studying something called the photoelectric effect, and that is something that was discovered by Albert Einstein and helped him to get the Nobel Prize, not the relativity, by the way. So anyway, so this is some way of changing the light energy into electrical energy simply, so it will emit electron. So of course, you can see this is a more technological, more recent, modern technology, and this is the main way for us humans to hopefully get our energy to be more renewable. In fact, I'm not sure if you realized, many of your calculator, like the one that I'm holding here, is powered by solar energy. So here you can see, this is of course a screen itself, right? But then you can see here, this is the photovoltaic cell. People just call it solar panel, but then this is a proper name. Then you may ask, hey, are you kidding me? Because you may think that, hey, if I cover this, you can still do anything. You can still operate properly, right? So the thing is, these calculator, again, it depends on different model, but then this calculator, it is powered by dual power, but then I don't think it's easy to read here, but then if you have one, you can go and read it. And that actually means it is powered by the battery inside, as well as the photovoltaic cell here. So that means if only the battery inside went out, then, and also the light energy is not enough, then that's the end of it. So in order to show you the actual physics in it, I will use my calculator as an experiment. Okay, so I will open this up and then take out the battery, and I'll show you whether or not covering this will make the calculator goes off. so you can see I open this up, and then you could also see here is the battery. So well, just to show you, it is still on, and I can do, you know, all sort of calculation properly, and then like this. Okay, and then now what I do is I'm going to take the battery off. Because the reason why I know how to do this is because once I ran out of battery, and then I realized I could only use, wow, it is so old, by the way. It's almost like, you can see the rust, and you know, those yeah, oxidize, whatever it is. Okay. Yeah, I once ran out of battery, and I realized I can only use a calculator when there's light. So then I realized, yeah, the batteries went out. So right now I took out the battery. There's nothing in here, and then let's see if I can switch it on. Okay, so actually I can't, because I think the light energy is not enough, because now it's actually at night. Okay, I have a light at the top here, table lamp, which is, wow, really strong. So I hope oh, it works. It works, right? So let's do cosine 45. Okay, it's actually pretty good, right? So without the battery, all right, and then it come back up. All right, so one funny thing is, if you try to cover this, can you see that it's like gone, right? It's like those magic power got shaded, and like those movie, right? All right, if I cover it for too long, I don't know whether that would kind of wash the memory away. Actually, it's actually pretty good. You can see it can still kind of keep there. All right, so okay, interesting. All right, so now it is gone. All right, I'm going to put back my battery. Okay. Oh, the cosine 45 is still here. All right, so somehow I don't know how, but it has a way to store probably the state of the memory state itself, just kept there, and then until you power it up again, it just come back. All right, so that means if now I'm using it inside this room without the light just now, I'm draining the battery. So yeah, so this is what it is. It will eventually run out the battery, and I will have to replace it if I do it in this room. So if I use this calculator under, you know, much stronger light, for example, the exam hall, usually that's how I find out somehow calculator works when I was having the exam, but not at home. So yeah, I think this is something very interesting for you to look, and maybe next time you know how to resolve this issue. Before we jump into the question, I would like to show you an interesting article that I find. This is an article from 2020 April, and this is a very popular topic actually, talking about people are trying to make transparent solar panel. So the most important thing is the idea itself, because the problem with solar panel is basically take up space, and it will block the light as well. Imagine if you could make a transparent solar panel somehow. Actually, the working principle is by capturing those non-visible light, so including, it could be infrared or ultraviolet. And if you can capture those energy, then you can basically install anywhere around the city, and people don't really care like whether you install it or not, because it's just like the window that we are having. So imagine the scale of the installation here. So I'll put a link in the description. If you are interested, please go to take a look of it. Okay, so finally we are on a question, right? The actual calculation question. So pause the video, try yourself, and we'll go through it together.
A few moments later.
Okay, this kind of question is actually very easy to do. As long as you know how to check the unit, you don't need to have any equation basically. So the first thing that you may want to see is this is the intensity of the solar radiation going to the Earth, and you have an array of photo-voltaic cell, and there's an efficiency. They want you to find the area A in order to get these as power. So if you compare the unit, then you probably should know it's 245 times the area, because area should be in a unit of meter square. So if you multiply it, you get watts basically. However, this is the input, right? Because this is what you have from the sun. So this is like the input. So therefore you have to multiply the efficiency, because you will get less out of that. And eventually you need to have 2.5k watts. So let me just put down 2,500. Alright, so then by using your calculator, you should be able to find the answer. That is around 51.02. I will round it up to 2 sig fig, that is 51 meters square. Very simple, isn't it?